Hello my dear students, welcome to our program for chemistry third secondary stage. Chemistry is very important for our life. Chemistry is a very nice thing to study.
Catch this word now, chemistry, that we need to start work. I think you are ready now. What about to go? Let's go. Chapter 4, Electrochemistry. It's great and easy. Try to concentrate for this interesting chapter. It's beginning with this.
With the meaning of electrochemistry. What's meant by electrochemistry? It is a branch of science that cares studying the changing conversion between the chemical energy and the electric energy.
Conversion to chemical to electrical. It's easy to say that. Through oxidation and reduction. So, all of this chapter depend on this word, oxidation and reduction. Now, look at this. Oxidation is loss
of electrons.
It's good. Reduction means
is gaining of electrons.
Now, the important comparison between oxidation and reduction, losing and gaining. Important chapter. Oxidation and reduction not stopped for the chemistry only, but in different part in our life, from the human, devices, materials, substances. Now, for example, we're beginning for the human. To know that, look at these materials.
So the materials here, it represents some equipments to what? To increase the losing or represent the losing and gaining electrons here inside our bodies. We have charges. We have positive and negative charges here in our bodies that has loses and gaining electrons. So here these materials represent
electrochemistry, which depending on oxidation and reduction, these particles, these ions move through our nervous system as you see. This motion is important. Nutrient process, it means growth cones, all of them depending on oxidation and reduction. What else for this?
Here we have some charges that move inside what? Inside the tubulin, inside this neuron here. To what? To make message between the nervous system and what? And all parts of our bodies. So here the neuron here, and we have growing, and we have many things like this to make what? To make growing. It contains the charges here, or electrochemistry is one of these parts.
The motion of the cell for this case is important to tell me what happened inside human. The electrochemistry for the human depending on the motion of ions as you see. So these ions may be positive, may be negative. It means losing or gaining. This it means we
have equilibrium or constant between what? Between them. We have equilibrium between this, or balance between these positive charges and negative charges.
Directly oxidation and reduction. My lover, this not all for the human.
Here we have the ions. We have here the charges. We have positive charge and negative charge here. We have mercury, and we have another one, GTP. It makes what? It makes the like batteries or like electricity inside our nervous system. Why? Because this one, it's positive charges and negative charges to move signals or electric signals from what? From our brain to all parts of the body. Through what? Through the neuron. Through what? Through nerves. So here, this is the process. What about this one?
This means you are a battery. Do you agree you are a battery?
Yes.
A human is a big battery because the reaction inside the human depending on before and after adding for example, mercury. So it's changed back to oxidation and reduction. The battery for the human is important. Where is our battery you find?
Here we have the battery. It's in our brain and nervous system.
It's good and extended through all the body, which give different impulses, and the different particles give electrochemistry.
So here we have a spontaneous redox reaction can be expressed by the following reaction. We have many reactions that makes this. This is one of them. We have Zn plus Cu plus 2. It means ion of copper that found inside a solution. It is aqueous solution. For example, copper sulfate. Give us what? Give us Zn positive 2 plus Cu. It's what? It is the solid precipitate. What will happen here in this reaction?
This reaction back to the spontaneous, it means you have oxidation. Zn will lose to the electrons. It means make oxidation. Also in the same time, Cu positive will be Cu only. Reduction, oxidation and reduction, it means you have spontaneous redox. Reaction is not a stop. Fly to this one.
We have what is the oil ring. It is what? It is the type of letters to make what? To make each one of this letter, it's what represent the redox reaction. Oil, it means oxidation is losing electrons. And we have rig, it means what? It means the reduction. It's or is the gaining electron. So here we have the oxidation and the reduction or redox reaction. They are both or they occur in the same time.
Now look at this. Oil is oxidation, is losing electrons. Zn lose to electrons, Zn 0. Directly it means Zn positive 2. Why? Because we say lose to electron. This is oxidation. After that,
the zinc atom loses 2 electrons and converts into zinc ion at cathode. What's meant by cathode here?
Cathode directly, it means this is a -1, negative pole. Also, you have red is reduction. It means again electron. Cu positive 2. It means gain 2 electron to Cu 0. Positive 2 plus electrons. We can say
the copper ion gains 2 electrons and charged into copper atoms at anode. What's meant by anode?
Positive directly, we say positive pole. Now the difference between cathode and anode, copper and lead or zinc, it means oxidation and reduction.
Now we have a little one of these exercises. Does each half equation show the oxidation or reduction? Which one is oxidation? Which one is reduction? We have the first one, 2Cl negative. It gives us Cl2 plus 2 electrons. It means what? Oxidation or reduction? Here we have the oxidation. Why? Because here we have 2 electrons that lose these 2 electrons by what? By 2Cl negative. What about the second one?
Aluminium here, directly it gains electrons. So what is the type of this reaction? We say reduction. Why we say that? Because it means you gain 3 electrons. Good and great. Take the other equation.
Here we have 2O negative 2. We have O2 plus 4 electrons. They are similar to the equation here. So we put it inside what? Inside the equation table. So here the oxidation. Why? Because here 4 electrons that lost by 2O negative 2. And we have another one.
Copper. Copper here, I think it's look like aluminium. Aluminium, it means reduction. So we'll try to put in the same place because you gain 2 electrons. No, it's lost. So it's reduction. What about the other one?
Other one we have Zn plus 2 electrons that give us Zn. It is like the first one before. We have here, it is reduction. What about the magnesium?
Magnesium, I think, look like aluminum and copper, zinc, and so on. So we'll try to say it's a reduction. Good and great. Look my level. You have oxidation, oxidizing agent, reduction, reducing agent. Oh, there's the other question. Now, look at the reaction and try to find the answer.
So the answer here, which one is oxidized, the copper oxide or carbon? So here, the copper oxide, it's what? It is an oxide that changed here to what? To the copper. But here we have the carbon changing into copper dioxide or carbon dioxide. Which one is oxidized? Here, try to make this carbon. Why? Because the carbon here, it's add some kind or some amount of oxygen in the copper dioxide. But we have the copper oxide changed to copper. What will happen here?
Copper oxide here lose directly oxygen. When it loses oxygen, will fly to reducing agent, copper oxide. Reduced. It's good to differentiate between them by losing also oxygen or gaining oxygen. So we have another comparison between oxidation and reduction depending on oxygen. Do you agree?
Yes.
Do it now.
Here we have what? We have this is oxidation and reduction between what? Between these two compounds here. We have the losing here of what? Of the electrons, and between what? Between the copper oxide. We have gaining electron to change it into copper atom, and we have the carbon that's lose electron to change it into copper dioxide.
This is back to the different types of the cells converted to chemical energy to electrical energy. After oxidation and reduction, sure, we have as a cells tell me that this is happening through redox reaction. That are what?
That are galvanic cell. This is the type of cell that represent the electrochemistry here. The electric energy changed by chemical energy. Number one is galvanic cell, and number two, we have electrolyte cells.
It's good. Now, you have a big difference? Sure. The first one, galvanic cell. What do you know about galvanic cell?
Galvanic cell, it is an electric cell from which we can obtain the electric current as a result of spontaneous oxidation reduction reaction or redox reaction. So, it is an example of Daniell cell.
Good, Daniell cell. It means depending on also spontaneous reaction of oxidation and reduction. Look this and answer with me. My lover, this is the shape of Daniell cell, which contain two halves which are joined together by bridge. But not this right. What about to see this video?
Here we have the first half of the galvanic cell. That contains what? That contains copper sulfate here. And we have another one here, or another part after making reaction of this reaction between zinc and copper sulfate. What will happen? What is the difference between them? We have zinc that react with copper sulfate in aqueous solution, give us zinc positive to aqueous solution and the copper solid. So here we have the type of this reaction. It's what? It is the galvanic cell.
This reaction depending on transferring of the electron between the two halves. I want to know how can the electron transfer from zinc to copper or from copper to zinc. This means you have zinc sulfate, which decomposed into zinc positive and SO4 negative. We have a bridge, salt bridge between them. It means sodium sulfate. When it's inserted in the other copper sulfate, also decomposed to copper and sulfate. Now, what about the reading that we see above the lamp?
Here the lamp makes what? It makes 1.1 volt. So we have electric energy that produced from this cell. That electric energy that concentrated or produced from the chemical reaction. So here the ions of zinc positive 2, it moves inside the liquid through the bridge to form what? Or to reach the copper plate. So here the copper plate, it's positive pole, and the zinc plate, it's what? It is the negative pole. So here the zinc is anode and the copper is cathode. Each one of them, it has reaction. What are the reactions here?
Oxidation and reduction. Oxidation from the zinc it means lose 2 electrons in this aqueous solution. The electron transfer from the negative to the positive. The other half, it has copper, which is a reduction. This copper transferred to electrons, as you see. So it passes from outside, from anode to cathode, but from inside is the opposite.
So the reaction here, we have two types of reaction. We have oxidation and reduction. The oxidation reaction at anode, it could be expressed by the following equation. What is the equation here?
Zn 0, it will losing, it will be Zn positive 2 plus 2 electrons. After that, you have the reduction reaction at the cathode, could expressed by the following equation.
We have Cu positive 2 plus 2 electron, that gaining electron here that happen to make reduction, forming what? Forming precipitation of copper solid. It's copper, red copper, that found here in this equation.
The reaction between the two halves depending on Zn for the oxidation, copper for the reduction. After that, they follow electric current between the two halves of the cell is stopped when all zinc metal dissolves in zinc half. Oh, can be zinc dissolves? Do you think that?
Yes.
How can do that?
By losing electrons here. The reaction in the galvanic cell contains any two elements. It's what represented by the following diagram. We have the diagram here between the two halves of this cell. It will be what?
Zn 0 per Zn positive 2. All of them equal for the other side per 2. Copper positive 2 will be copper 0. Oxidation and reduction.
We have here, this is the lines that found between these symbols here. These symbols, it may have what? Number 1, or the first line, it means zinc plate or zinc atoms dissolve in the zinc sulfate. And between them we have parallel line that represent what? Represent the solid bridge between the two halves of the cell. And the last one, we have the one line between the copper and the copper positive 2. It means the copper plate dipped inside the copper sulfate positive 2.
This explanation for the reaction between the two halves. I ask, what is the salt bridge? Salt bridge, directly we say it's very important. What is the importance of its galvanic cell? That we must learn it. Salt bridge that join between the two halves. Say